Hello students, today I'll discuss with you dispersion and spectrum of light. What kind of light sun gives to us? Sun gives white light. Yes, that's true. Then why do you see 7 colors inside that light? Why is the light appears violet, indigo, blue, green, yellow, orange and red? Are these light something different or are these light just the same? What is that thing which decides the color? So how can you differentiate a red and a violet light? See, light is a wave. A wave is something like this. It travels in the medium. And this is known as one wave. Just like this is one wave. This distance of one wave is called wavelength, denoted by a symbol lambda. It is lambda. It's a Greek symbol for wavelength. This is a characteristic of all the light you see or whether you don't see. There are some kinds of light that we cannot see, like X-rays, ultraviolet rays, infrared rays, radio waves, microwaves. But those lights also contain wavelength. So what makes red color different from violet is wavelength. See this is some kind of red light and this is violet. Can you see some kind of difference between these two rays? There is. This red light has large wavelengths. See? This wavelength is large. And violet has, this is wavelength, whatever you say, one wave. And violet has very small wavelength. Very small as compared to red. This makes violet light different from red color wavelength. Violet has the minimum wavelength, very small wavelength. See, this is so small in comparison to red. It's approximately about 400 nanometer in air or vacuum. And when you compare it with red, which has maximum wavelength, the longest wavelength, it's about 800 nanometer in air or vacuum. Among the visible color, that is violet, indigo, blue, green, yellow, orange light. This is visible light. Visible light. Violet, indigo, blue, green, yellow, orange, red. This much is only the visible light. Among the visible light, red color has maximum wavelength, 800 nanometer. And that makes red color different from violet color. Similarly, the other colors have wavelength in between indigo, blue, green, yellow, orange. They have something in between these two wavelengths. Okay. What do you know about the speed of wave? If this is light and if this is a wave, it is traveling with a speed of 3 into 10 to the power 8 meter per second in air or in vacuum. Yes. What is the speed of red light? What is the speed of violet light? All colors travel with this speed in air or vacuum. All colors. See, red has a long wavelength, no problem. It will travel with the same speed as violet. Both will have same speed in air or vacuum. But you will ask, how is that gonna happen? Suppose they have to travel equal distance. Yes, approximately equal distance. This distance, let me make it equal. Let me design it equal. Let me design it. Is that equal? Yeah, that's it. So red and violet travels equal distance, fine. But red has large wavelengths. See, this wavelength is so large when compared to violet. How many waves of red are here? One wave and a half wave. One wave and half wave. And how many of violet? 1, 2, 3, 4, 5 and 5.5. So number of wave of violet color are more as compared to number of wave of red color. This is known as frequency. What is frequency? Number of wave. So this is how it is possible. Violet has a small wavelength, that's true. But the number of waves of violet are more. So we say frequency is more for violet and less for red. Are you getting the frequency term? It is the number of waves. Number of waves. How many waves are here? 1.5. 1.5. How many here? 1, see, 2, 3, 4, 5. More number of waves. So, in order to travel at the same speed, both have to travel at the same speed, cover equal distance in equal time. In order to do that, in order to travel equal distance in equal time, violet has to produce more number of waves, and that is frequency. So violet has more frequency and red has more wavelength. What is frequency? Number of waves produced in 1 second. Okay. There is one formula that can relate it all, and that is V is equals to F lambda. V denotes speed of wave, F denotes frequency of wave, and lambda denotes wavelength of wave. Okay. See, this speed is same for red and violet color in air or vacuum, but red has more wavelength, so it needs to have less frequency because its wavelength is more. It needs to have a lower frequency, so that on multiplying you get that V same, while violet has less wavelength, so it should have more frequency. Am I making sense? Are you getting up to that point? So violet has very small very small wavelength and very large frequency. So your point is, how are you gonna remember that? You have understood it? You have known, yes, this is happening. Red travels with large wavelengths, violet travel with small wavelength. So violet needs to produce more wave. So violet has more frequency but less wavelength, and speed is same for all colors. But how are you gonna remember this? There's a trick. There's a method. Let me tell you that. Okay, so what's the method? What is the logic behind it? If I tell you a statement, Viola has maximum rediff accounts. Viola is a girl, she has maximum rediff. Rediff is something like Google. It used to be in our age. Nowadays not that popular. I don't know about it. Leave it. Rediff accounts. So Viola means violet. Light, of course. Has maximum R. R is refractive index. Okay. So you are not interested in this. You are interested in this. This is frequency. So R has maximum frequency, maximum refractive index, and these two terms are from previous chapter. One is deviation and one is displacement. Which displacement? Lateral displacement. You must have studied this in previous chapters. when light passes from one medium to another, it bends. It always bends. And it bends because of the refractive index. Yes, because of the density change. So, violet has maximum refractive index and maximum deviation, maximum displacement and maximum frequency. Is there wavelength written anywhere? No. So violet does not have maximum wavelength. It has maximum frequency and very small wavelength. So this was the way you can remember this. Now, coming to this point, refractive index. If you remember, refractive index is inversely proportional to speed of light. Refractive index was inversely proportional to speed of light. Refractive index of second medium upon refractive index of first medium is equals to speed of light in first medium upon speed of light in second medium. So this refractive index things depends upon speed and it is inversely proportional. So if someone has less speed or great speed, it will have different refractive index. Refractive index depends upon speed. Now in air, all the colors have same speed. All the colors have same speed. So their refractive index in air will be same for all the colors. So all travels equal distance, all travels in a straight line, all show same characteristic, same property. That's why you cannot much distinguish them. They are mixed. They are traveling equal distance. They are mixed. And they form white light. When all these colors merge together, you cannot see any one color. They are so similar. They have same refractive index, same speed. The only difference is wavelength, but that is due to merging. We cannot perceive. Human eye cannot see it. So we see white light. But when these colors enter into medium, in any other medium, red travels fastest. Oh my God. Now what has happened? Look what is happened. When we go in glass, when we go in water, red starts traveling in the fastest speed. Red takes the maximum speed. Not in air, not in vacuum, in any other medium. Red travels with the fastest speed. Now you come to this formula. Refractive index is inversely proportional to speed. So inside glass, red has the maximum speed. This is maximum. So its refractive index will be minimum. And in any other medium, violet travels slowest. We don't know why these colors slow down. That's nature. Red travels fastest in glass or water. Violet travels slowest. First of all of them are slowed down. When we go in glass, water, oil, such kind of medium which are denser than air, then these particle of the medium slows down light. But they are not equally slowed down. Red travels fastest. Red is not that slowed down. It is running with the fast speed. And violet travels slowest. Violet is slowed down to the maximum extent. So in any other medium, the speed does not remain same. Now there is a change. Red is running forward. Violet is coming backward. Now these colors split up. They are no more a single color. Now they split up. Violet goes in some direction, red goes in some direction, and you can see all the colors different. Now this splitting is what we call dispersion. Splitting of white light into 7 colors. Why does this happens? Because different colors of light travels with different speed in any other medium except air or vacuum. In air, they travel together, we cannot differentiate them, we see white light. But in the medium, the light from the sun that we see as a white light consists of 7 colors. We put a prism in the path of white light that is coming towards us. White light contains all the 7 colors, traveling equal distance in equal time, coming towards the prism. Now what happens? Red travels fastest and violet travels slowest. They are separated, and this phenomenon of separation is called dispersion. So white light is made up of 7 colors. Those colors were traveling at equal speed in air and travels with different speed in different medium. Coming to this point, this is very important. Violet travels slowest. So this is speed is minimum for violet. And speed is minimum, so refractive index is maximum. Violet has maximum refractive index. Refractive index decides that how much bending is going to take place. I give you the value of refractive index of glass 1.5 and water 1.33, which is more denser. That medium which has more refractive index. Glass has 1.5, water has 1.33. So glass is more dense. So refractive index decide which medium is denser. And the more denser the medium is, more will be the bending of light. More the light will bend. Light bends because of change in medium. If medium is more dense, light will bend more. Okay. So violet travels slowest, speed is minimum. So refractive index is maximum. When refractive index is maximum, then bending of violet light will be maximum. Suppose white light is coming and violet splits up. Violet splits up most because violet is bended most. Violet is deviated from its original path most. So violet has maximum deviation. Violet has displaced from its original path most. Violet has maximum displacement. So this you need to understand in a very simple manner. Don't rush on this topic. You got to have the real concept. So violet bends most. We get another line, that is violet bends most. Why does violet bends most? Because it travels slowest. When someone is traveling slowly in a medium, you can easily change his direction. You catch the violet light, drag it. But red is traveling fastest. You cannot change its direction. So red does not bend that much as violet bends. Now suppose white light is coming like this, and here is a prism. Here is a medium which is not air. When these light enter this medium, violet bends most and red doesn't bend that much. So there is a splitting, and that is called dispersion. What happens to wavelength and frequency when light enters any other medium? Frequency is something, students, which is designed in nature. You cannot change the frequency of light. You cannot. We cannot. Mediums cannot. What is frequency? Suppose in 1 second, I beat this for 3 times. How many times you are gonna hear that? 3 times. And that is frequency. Number of waves produced in 1 second. That depends on me. That does not depend whether you are watching me on your mobile phone, underwater, or somewhere in air. That does not depend upon you or the medium. That depends upon me, the source. So frequency remains unchanged when light enters other medium. Frequency cannot change. Frequency remains same. So you can say that frequency of violet is still maximum and frequency of red is still minimum, and the value is also the same. What do you think about wavelength? The next thing is wavelength. Will it change or will it remain same? See, I told you a formula. V is equals to F lambda. When light goes from one medium to other, its speed changes. The denser medium slows light, so speed has to change while changing medium. And for frequency, you say frequency remains unchanged. The frequency remains unchanged. Now, how will this speed change? With the help of wavelength. So wavelength also changes. Whenever you change the medium, speed changes and wavelength changes. For all the colors. For all the colors it happens. Violet's speed is decreased very sharply. It becomes very slow. And red's speed is not decreased that sharply. Frequency for all remains same. Whatever the number of waves were there in air, that will be the number of waves inside the medium. But violet becomes slowest and red becomes fastest, and all of their speed is lesser as compared to their speed in air. In air, light was travelling at 3 into 10 to the power 8. Red was also 3 into 10 to the power 8. Violet was also 3 into 10 to the power 8. But in the medium, all of their speed have decreased. Red's speed is not that much decreased and violet's speed is very much decreased. Frequency remains unchanged. So if speed has to decrease, wavelength also got to decrease for all colors. For all colors. Now which will have maximum wavelength or minimum wavelength? That will be the same. Red will have maximum wavelength, violet will have minimum wavelength. That won't change. Wavelength is still maximum for red and still minimum for violet. But their values have changed. Now there's values 400 of violet and 800 of red in nanometers are not valid. So whenever the medium changes, what happens? Light slows down, red does not slow down, violet slows down very much, red travels fastest, violet travels slowest, frequency remains unchanged and wavelength also changes. Since red travels fastest, it cannot bend that much, violet travels slowest, so it is bended too much, violet has maximum bending or maximum deviation. This much you have got. That was the hard part of this topic. Now you can speed up. That you need to understand. For the first time you were learning all these things. Now see, if I have a prism. I have a prism. And I have white light over here. This is white light. And now you know this is not white. It contains 7 colors. Now this light is coming. It goes to prism. You will draw a normal here. This is normal, which is perpendicular to the surface. Now light is going from rarer to denser medium. It will bend towards the normal. So all the light starts bending. But which color will bend most? Violet. So violet bends most and red bends least. Violet has maximum rediff account. Rediff, refractive index. E, nothing. D, deviation. Violet deviates most. Here you draw normal again, like this. Normal, perpendicular to surface, like this. It goes from denser to rarer it will bend away from the normal, violet, red. Here is the screen. On the screen you see violet light at the bottom and red light at the top. Red at top, violet at bottom. Indigo, blue, green, yellow, orange and red. So as we are thinking that it is violet, indigo, blue, green, yellow, orange, red, it happens opposite. Violet is at the bottom. This phenomena of splitting of white light into its constituent colors, this phenomena is called dispersion. And what is the cause of dispersion? The cause of dispersion is different colors travel with different speed in mediums except air and vacuum. Red travels fastest, violet travels slowest. Violet bends most, red bends least. And this image, what is this image? We have red light over here, then another, then another, then another, then another. Like this we have violet, indigo, blue, green, yellow, orange, and we have what? Red. It's a two-dimensional figure. The prism is 3D, so it will be lines. There will be lines of colors. This band, this is something like band. This band, the band of colors obtained on screen is called spectrum. So these are two phenomena, two technical terms you need to remember. What is dispersion? Dispersion is splitting of white light into 7 colors. And what is spectrum? Those 7 colors when form an image. Those 7 colors when form a band of colors which is obtained on screen. That band is called spectrum. Okay. And in spectrum, violet is at the lowest position. Where does dispersion occurs? At this surface or at this surface? So you will say at this surface. Here dispersion is not occurring. Here just bending is occurring. This surface separated the two colors more. They were already separated. Now they are more separated. But dispersion has occurred on this surface. Dispersion. Now, normally there cannot be one white light entering a prism. There will be number of white light. One white light will come like this. Its violet will go like this. Red will go like this. Violet bends more. And violet will form image here. Red will here. One white light will come like this. Its violet will go somewhere here. Red here. One white light comes like this and similar thing is happening. Let me show you what can happen. In reality, there won't be one light. Nah? How can you get one ray? There will be more number of rays. Suppose one ray is like this. This is also white light. Now it separates. Violet bends most, red bends least. Violet, red, indigo, blue, green, yellow, oh, and some white light is like this, and this is happening. You're right. You won't see 7 different colors. Instead, you will see all the colors overlapping over one another. You won't see that good spectrum that you are expecting. Such an spectrum in which different colors overlap is called impure spectrum. And if somehow you can distinctly see different colors on the screen, that means your spectrum is perfect. It is the pure spectrum. Pure spectrum. A pure spectrum is one in which the different colors can be distinctly seen without any overlapping, and that is pure spectrum. So this was all about spectrum and dispersion.